Advanced Deep Learning Workshop. It is my privilege to introduce today's distinguished speaker, Mr. Tushar Kute sir, who will be enlightening us on recurrent neural networks and LSTM models. Tushar sir is a senior data scientist and trainer at MITU Research, Pune, with over 20 years of experience specializing in artificial intelligence and data science, machine learning, and big data technologies. His expertise lies in delivering advanced solutions in training, empowering teams, and driving innovation in the industry. He is currently pursuing his PhD in computer engineering at VIT Pune and holds a bachelor's degree in computer engineering from COEP Pune. With an impressive academic record, Sir has authored 10 international journal papers and 17 international conference papers. In addition to his role as a data scientist and trainer, he has also contributed significantly to academia as they with an impressive academic record, Sir has authored over 10 international journal papers and 70 international conference papers. In addition to his role as data scientist and trainer, he has also contributed significantly to his academia by as a visiting faculty member for professional technical courses at institutions such as Center for Development and Advanced Computing (CDAC) and MIT MIT Academy of Engineering (R&D), and several other esteemed colleges across Maharashtra. Sir, it is an absolute honor to have you here today. I would now request Anjali ma'am to felicitate Sir. Sir, we kindly request you to accept this token of appreciation. Sandhya ma'am? Okay, I would also request Sandhya ma'am to felicitate Sir.
हो नाही नाही गुगल मीटला वाजून आहेत ना ह्यांनी नाही जॉईन केलेली. हॅलो हॅलो
हेलो ओके लेट्स कंटिन्यू हाँ वीडियो चालू है I hope you're knowing the concepts of neural network already. What exactly the meaning of neural network? Is it so? Means how? What's the meaning of input layers, hidden layers, output layers? हाँ का हाँ हेलो हेलो ये तो है ना ठीक है गूगल मीटला ऑडिबल आहे ना अच्छा ठीक है okay so I think you may be knowing the concept of neural network. Is it? Knowing means, for example, if I given a problem statement ki this is my data set and you have to build a neural network for this. So you have to define your neural networks input layers, then hidden layers, then output layers, and accordingly we have to train the neural network, and then we can find the solution to that problem. Is it possible for all of you? Means I just want to know whether the core concept of neural networks are known to you or not. Which library you have used for that? Libraries? Torch. Miss Torch. Keras? Have you used Keras library? Yeah? Have you done the thing practically or not? You have done this. Actually, why? Because our topic is recurrent neural network here. And in order to understand recurrent neural network, the common idea of neural network should be known. What do you mean by neural network? And because it's the extension of it. RNN is the extension of the basic neural network there. Let us see. Let's have an overview of it, and then we'll talk about 3 different concepts here. The first topic is RNN, basic. What's the meaning of RNN? Then there are some modification made under the RNN, that is LSTM first and then GRU. What is the usage of it? Why these are modified? Why they are used? And one very simple practical application of it without data set I will show you. What is the role of neural network, recurrent neural network especially, inside the building this particular model? What is the purpose? What's the main reason of using recurrent neural network? That also I'll show. I'm having many programs with me. I used to teach the same subject to various different institutions where deep learning and artificial intelligence is used as the main subject, because currently today's generation AI is basically based on deep neural networks, all, whether it is image based or text based. When you talk about the text based, let's see what is the biggest artificial intelligence product available today which is based on a text is your ChatGPT. Correct. It uses the data as a text, generated data as a text, and the processing is done with the help of some neural network based models that they are based on transformer actually, but they are text based. They are text based. So their base basically start from recurrent neural network here. First RNN, because whenever you have to work on text based data, you should know how exactly RNN works. Then ahead of next technology, next, and currently whatever we are using is a pre-trained transformer, that is GPTs. How they are built. So in order to understand them, we should understand how recurrent neural network basically works. But before that, how neural network works, that we will see here. See, neural network. I hope you may have seen this diagram multiple number of times. It's a base of deep learning. Why deep learning? Because deepness of this architecture is defined by ourselves. Currently here 3 hidden layers are there. We can have 10, 20, 30, 40 also. Various different computer vision models are available today. They are having 200 plus layers also. They are available. That's why they are called as deep neural network. What's the main logic behind it? Let's explain the logic. I'll revise that logic. I hope you may be knowing this. See, deep learning or deep neural network basically comes under one common idea, that is artificial intelligence, AI. Correct. So AI is a common term. What's the meaning of AI? AI means human intelligence is represented in the form of computation team. Means computer, whatever human being does, all human cognitive abilities will be performed by the machine. That's called artificial intelligence. But in order to do that, we require some technologies, like for example, I can hear the voice, I can understand it. I want computer to do the same. I can see the visual world, and then I can understand what is present, what is moving, what's the color of it, anything. but I want computer to do this. Or I can learn from experience. I want computer to do this. I can solve the problem. I want computer to do this. So in order to do this from the computer point of view, we require different technologies of AI. Different technologies of AI. Under this, one technology, machine learning. I hope you are knowing machine learning also. What's the meaning of machine learning? Can anybody elaborate? What's the meaning of machine learning? Let's finish this part first and we'll go with RNN there. What's the meaning of machine learning? I just want answer from one of the students. Yes. You can raise your hand. Anyone? What is machine learning? Oh, don't know? Actually train the model in the sense we are having previous experience with us. We are going to use previous experience. Okay, that previous experience is used to find a pattern present inside it. We have to fit the data into pattern. Once we found the pattern, then we can use that pattern to perform the predictions ahead. Basically, the common idea, whatever happens in the world is having a pattern present, mathematical pattern there. We have to find in which mathematical pattern this data is fitting. It may be fitting in most of the patterns there. Wherever it is fitting, we have to fit them, we have to train them. Fit means train. Train them. Once it is trained, we know the pattern, we identify the pattern, and using that pattern, we are going to perform the predictions ahead. This was happened in the past. Now what will happen in future? That we have to find. That is what we call as machine learning. Common idea of machine learning there. And for machine learning, various different kind of algorithms are available that we are using. Maybe if you heard about decision tree algorithm, k nearest neighbor, support vector machine, new bias classifier, logistic regression, linear regression. What they do, they exactly use the previous data, they find a pattern present inside it, and once they found a pattern, they perform the predictions ahead. That is what we call as machine learning. How do we learn? We learn from experience. Computer algorithm will also learn from experience. We have to provide input as experience there. So every algorithm of machine learning is having their own idea to find a pattern present in it. Actually, whenever we decide by our brain, whenever we decide anything by our brain, then also we are used to have some pattern. We used to have some pattern there. Using that pattern, we perform the predictions also. Using previous experience, you do this thing. Like for example, if I ask you, what is the probability of having rain today? What is the probability of having rain today? What is that? What do you think? What is the probability of having rain today? It may be not even 1% also. Correct. How do you decide it? Because you already observed what condition leads to have a rain. And these conditions are not present today. That's why maybe it's very difficult or almost 0% probability to have a rain today. Because you have observed it today. Observed already, using that you perform the predictions. Same ideas are used in machine learning there. And definition of machine learning is applicable to deep learning also. Their definitions are exactly same. Deep learning also does the same method. They use the previous data, they find a pattern present inside it, they perform the predictions ahead. Basically, human being learnability is also having a pattern, knowingly, unknowingly. We use some pattern in our brain and accordingly we perform the predictions there. That is the base for the machine learning, and same idea is used in deep neural network, deep learning also. What's the idea there? See, for example, I have shown you two animals. Okay, one is zebra and another is horse. And I will ask you, which one is zebra, which one is horse? What exactly we do first? We extract the feature from that particular data which is shown to you. Features. Feature means how many legs are there, you'll see that one. How the eyes are looking like, what's the shape of that animal, how the tail is looking like, what's the skin color there. Like all. These are features you extract. Our brain extracts this feature with the help of our 5 sensory organs. Maybe not all 5 are used. 2-3 different organs, sensory organs we'll use, and accordingly we extract the feature from there. And then we decide which feature is very important to classify them or to identify which between these two is horse or which is zebra. What is that? Skin color. Their shape is almost same. So shape is not a distinguishing parameter. What is skin color? So skin color, black and white strip, it's a zebra, and which is not, it's a horse. That will distinguish between them. Unknowingly we do the same thing in our brain. Means our neurons, our brain neurons are having this ability. They extract the feature using sensory organs, and accordingly, because already we have seen zebra multiple number of times, we have seen horse multiple number of times. Using that we are recognized which feature is very important that will distinguish between horse and zebra. exactly same idea is used by this neural network also. What they do, they require the feature. Input means features. Input data is your feature. And what neural network basically does, they identifies which among these 4 or n, 20, 30 features are very important. Which among them is very important. Means by using feed forward and back propagation, I hope you have learned about it. Feed forward and back propagation. They try to identify the suitable, ideal, optimal weight for the neuron. Everyone's weight will be initially same, but as your epoch progresses, they try to adjust the weights. So which feature is highly important, their weight will be higher. Which is lower important, that will be lower. It happens because we are having some bunch, n amount of data, like n number of rows are there, n number of inputs are given to it, and accordingly identify which feature is very important, which feature less important. That's why maybe if you have seen the difference between deep learning and machine learning is that deep learning is having inbuilt feature extraction method. They decide which feature is very important, which is not important. But in machine learning, it's not the case. We have to separately apply feature selection method, feature extraction method for machine learning there. Separately, machine learning is not having this ability, but deep learning is having. Why? Because their architecture is created like this. You may have learned about this. I just given the core idea. What is idea? What logic they have used? Human brain also does the same method. They find which feature is very important, which feature is less important, and accordingly the neurons' weights are decided. I hope you may be knowing these neurons are containing weights also. These weights are identified by multiple epochs, by a phase of sequence of feed forward and back propagation cycle. They identify ideal suitable weights for the neurons. So when next time a new feature comes, a new data comes, it extracts a feature for it, and accordingly the weights are given to them, will be multiplied. Weight means which feature. For example, input 2 is having weight 10 and input 1 is having weight 1 only. Weight is multiplied by that number. You might be knowing this. WXI, summation of all are taken and then it's given as input. Means which feature is important, that is decided by the weight particularly, and that is what the logic neural network basically contains. Common logic. They identify the suitable, ideal, optimal weight for the respective neuron, and accordingly the model is built. So when next time new feature comes, new data is given as input, as per the weights assigned to them, they will identify in which category the data will go. That basically for classification we are using. In regression also it is possible, but for classification we are using neural network for maximum number of times. That is the logic, common logic. Behind that logic there are various parameters present that you may have learned already. Optimizer functions hai, loss functions hai, which are used, learning rate hai, which are required for building a neural network. These are the hyperparameters that we basically apply, and accordingly neural network is learned. So inputs are given as input features are given, then every neuron is connected to every other neuron in the hidden layers. Multiple hidden layers are possible, decided by us. There is no any formula for deciding how many hidden layers should be there. It's a trial and error type of problem that you are facing. Based on that, hidden layers and hidden neurons are decided there. This is just a random diagram which is shown over here. So 3 hidden layers are present. Any number of hidden layers are possible. Then output layers, we are having 2 output layers or n number of output layers, single output layer. Output layer single, but under it n number of neurons or single neuron is also possible. Correct? I hope you are knowing this also. If you are having binary classification problem, then how many neurons will be there in the output layer? Binary classification problem. Very good. Any other answer? Binary classification problem, how many neurons should be there in the output layer? 1 or 2? 1, not 2. 100% 1. Okay. And if multi-class classification problem is there, then means for example 10 classes are there, then how many neurons should be there? 10. No. Okay, for binary classification only 1 neuron should be there, and what's the activation function should use? Sigmoid. Remember, so in neural network you may have learned about it. Sigmoid activation function, which is used for binary classification. It generates the probability from 0 to 1. If probability is going above 0.5, class 1 is predicted, below 0.5 class 0 is predicted. That is sigmoid. And when you're using multi-class classification, then which activation function is used? Softmax. Sure. Softmax is used for multi-class probability generator. Multi-class probability generator is distributed probability under n number of classes. Remember. Getting? So two activation functions are there which are used for classification in the output layer. What about the hidden layers? Which activation function is used? ReLU. Yes, everyone is knowing it. ReLU. It's a rectified linear activation function where it passes only positive values to the next layer. That is max of 0, x is a function that is required. ReLU is used for hidden layers. What about tanh? Have you used tanh anywhere? Tanh. You're knowing activation functions, correct? tanh. Let us see. tanh is not used anywhere. Used in recurrent neural network here. We'll see that one. How do I use it? Basically, whatever topic we have discussed, that is a pre-requirement for understanding the recurrent neural network. Because how neural network behaves, that we should be knowing. Input layer, whatever number of features are there, that number of input should be present. Neuron should be present. Hidden layer, there is no any formula for this. You can define as per your logic. How many layers and how many neurons per layer, that we have to decide by our own, by trial and error. And output layer, it's also fixed. When you are doing binary classification, one neuron with sigmoid activation function, and for multi-class, that number of whatever number of classes are there, that number of neurons with softmax activation function. These are the common requirement. Along with we are having loss function and optimizer function also, but they are commonly used depending upon the kind of problem that you are solving. We'll see this here also. Yeah, that is what we call as neural network. What is learning in neural network? Finding ideal, suitable, optimal weight for the neuron is called a learning neural network. Neural network has learned what should be suitable weight for that neuron and for that feature which you are passing. Okay. Done. Let's go ahead. There are multiple variants of neural network as created based on the problem that we have to solve. Okay, out of it, first a recurrent neural network, that is RNN. The first is recurrent neural network, that is RNN here. Okay, so recurrent neural network is a type of neural network used for sequence prediction task. Sequence prediction task. See, have you heard about lazy learning? Yes. What is lazy learning? Tell me the meaning of lazy learning. Anyone, just raise your hand. What is lazy learning? Which algorithm comes under lazy learning? Yes? You raise your hand. I just want to have an answer from your side. Which algorithm is there in lazy learning? Why? Reason. KNN are correct answer. What is lazy learning then? Okay, correct. 50% true. What is machine learning actually? Machine learning uses previous data. It finds a pattern present inside it. Once the pattern is found, after that, data is not used. We will use that pattern, that model to perform the prediction. But KNN is not that type. KNN uses their own data. And for prediction also they use the data. They don't use model. They don't have any model. They directly use the data for prediction. This is the only algorithm which does this work. Model should be there. Like for example, linear regression model, y is equal to mx plus c. You are finding the value of m and c. Once m and c is found, data will not be used. Decision tree. It builds a tree. Once the tree is built, after that data will not be used. They are called eager learning. They are not lazy learning. But in KNN, it's not the case. That's why KNN is not 100% machine learning. It's 50% machine learning. 100% machine learning is not. Machine learning means they should find a pattern. Remember, machine learning and deep learning definition same. Whatever machine learning, deep learning also does the same methods. So you cannot call it as a machine learning because it doesn't create a pattern. Same idea is used here also. See, algorithm, neural network, what neural network does? Neural network basically uses the data and accordingly they modify the weights. They learn the weights. But once the weights are learned, after that data is not used anywhere. It will be directly discarded. It will not be used afterwards. They are used to just learn the weights for the neurons. Correct. Now, my problem is something different. Sequence prediction task. When we have a sequence, this is coming after that. How it is coming is very commonly the things are coming afterwards. For example, whenever I type the mail, always a common sequence hai, whenever commonly, maximum 80-90% time, whenever you type thanks, then you type regards also. They are coming together. Sequence hai. Or if you type thank, then after that you is also coming. Sequence hai. These words are coming in a sequence, always in a sequence. I want to find such kind of sequences. I want to model this kind of sequences. That's why the neural network, deep neural network, is modified and they are created recurrent neural network over. That's the use of it. Sequence prediction task. Like I have given there, time series, speech, text. Always sequence, time series sequence is there. Always in. Like for example, sale of a company. According to time, it is changing. You can see the graphs present there. Time series data. Stock market data set, time series data. They are only having the time as the input and accordingly the output is changing. Sale is changing, profit is changing, margin is changing. Time series data, speech data. Whenever I am talking something, so I am having some sequence, means I basically use few words very together, common together. Am is always coming with I. It will not come with he, it will not come with it. Sequence hai. Correct. That is speech prediction, text prediction. So whenever the things are coming together, that time we have to modify the neural network so that it can learn the sequence. That is what recurrent neural network does. So how does it work? At each time step, the model takes input data, the previous hidden state, and compute the current hidden state based on it. Previous data is given as input to it, and accordingly they find the current state. So output is produced based on the current hidden state there. That is the logic which is being used by recurrent neural network over here. See this. So special type of NN adapted for time series data or data that involves sequences. Wherever sequence is there, then only we are going to use it. Where sequence is not there, you are not going to use this anywhere. Okay. So if the data that we are having in sequence such that one point depends on the previous data point. Correct? This case is not present there anywhere in the machine learning. Means previous data decide what can be the next one. That data decide what can be next one. That data decide what can be next one. This is called as sequence inputs. Now, if I want to model the neural network in this way, so definitely what was the previous input that should be known to neural network. But in deep neural network it is not the case. Once data is learned, it will discard it. That is your eager learner. It's not a lazy learner, eager learner. They use the data, once data is used, later data will not be used to perform predictions. But I want that data. Why? For what purpose? I want to learn the sequence for that purpose there. So we need to modify a neural network to incorporate a dependency between the data points. So RNA is having a concept of memory that we'll do. We'll see this common idea first. Check this. This is your basic neural network. Which one? This one. And this is your recurrent neural network. What is done over there in recurrent? So you have X as input, H are the hidden states, and Y is the output. Definitely everywhere we are using X as input, Y is the output. And here we are using H as the hidden state here. Every neuron is connected. It's a densely connected neural network. That's why dense layers we basically use there. Okay, and this is recurrent. What recurrent does, see here input hai, okay, and now the C is the output. Generated is given back to input again, to the hidden state again. Why? Because I want to learn the sequence. I should know ki what's the connectivity present between two different things which are coming together, commonly coming together. That's why this is created. This is called as recurrency. This is called as recurrency. Common methods are used. See this one. Here the output layer, hidden layer is there, and output is connected back to this neuron, which is called as recurrency, which is modified here. Why this is modified? Because they have to learn the sequence present or the connections present between two input which are coming together. Two input which are coming together in a sequence. That is what done in the recurrent neural network there. Why they are used? Because first thing is that deep neural network cannot handle sequential data. First, they consider only current input. Once current input is learned, then that will not be used ahead again. Okay? And they cannot memorize the previous input also. These are the three reasons why recurrent neural network is created. So solution is RNN, which can handle sequential data accepting the current input data and previously received input. Current input data and previously received input. Both are given as input to it. So they can memorize previous input due to their internal memory. That's possible. See this one. Wait a minute, I'll just show you a simple architecture of it. Oh, wait a minute, it's not running here. Hmm. You check this one. See, this is a recurrent neural network. Everywhere we are going to have the output of the first. This is input, hidden, Y output. Now see, the inputs are given and they are given back to the neuron again. And same is carry forwarded. Same thing is carry forwarded for all the hidden layers present inside it. For every neuron, these are connected in this way. Okay. Recurrency is created. Recurrency is possible, it's available for the recurrent neural network. So they can use both input, means current input and previous input also. Both are given as input to it. That's what recurrent neural network basically does. Yeah. So let's continue. I'll explain what exactly it does. See, so input layer X takes input in the neural network and processes to the middle layer, that is hidden layer. H will be multiple hidden layers are there. Any number of, you decide how many should be present there, which will have their own activation function, weights and biases differently. Weights different, bias different, activation function. Generally we use ReLU. Generally in all hidden layer basically we use ReLU there. If you have a neural network, then various parameters, whatever number of neurons, activation function, how many layer, everything will be decided by our own. There is no any formula present for this. Okay. Now, a common difference between them we have already seen. Feed forward neural network, generally whatever we use, directly they are having sequential data, first to second, second to third, third to fourth. But in recurrent neural network, we are having the connection created backwards. That is what basically RNN contains there. This is what feed forward neural network is containing. Okay. Now, where do we use it? We'll focus on few internal structure also, but where do we use it? The first application is your image captioning. See, this is image captioning. Have you tried something in Google? Wait, I'll show you this one. Whatever I given, a dog is catching ball in the midair. There are 6 different words or 4 minimum words are there. Dog catching ball, mid and air. These words are there. And the image which matches all of them, only that is taken out. It's not like only dog is there. Only jump is there. Whatever description I have given, accordingly is identifying it. See, for example, if I type the same question here, maybe if you have seen this, see, I'll go to images.google.com here, and you see this. So I just typed it already. See, this one. A dog is catching ball in the air or in the mid-air, whatever. If you see all the result which you are getting, they are exactly matching the description there. Whatever images you are getting. It's the output of recurrent neural network in image search. कि sequence है, dog है, catching है, ball है, air है, all this sequence, wherever the sequence is matching, only that images are taken out there. Correct. I'm not searching only for single dog there, but all sequence which is matching, that is taken. It's called image captioning. It is possible with the help of recurrency in the neural network. Okay, first one. Or if you go with some other examples, see this. This is what time series analysis is. For example, the blue one is my sale for 2014, 15, 16, 17 and 18. Sale hai. Month by month. Furniture sale hai. But if same trend continued, then how my business will grow in future? This is called a time series analysis, which is done. The red one is forecasted by RNN. Trend hai, according to time. Here we do not have, what is the input data over? See, whenever you show in neural network or machine learning, we should have two things: input data, output data. Correct? What is the input here? What do you think? Furniture sales are there, furniture sale, and that is shown ki according to date, the furniture sales are shown here. This is your scatter plot, line plot. Okay, and these are predicted by RNN. Ki now same trend continues, then how the sale will grow in future. That is predicted by algorithm, this red one. These are the prediction sale. So what do you think? What is the input data to this algorithm and output data from this algorithm? Input data is time and output data is? No, input cannot be time actually. Time wise? No. Time wise sale? No. See, RNN is a special case where we are defining input output by. They don't have input data. They are only having the output data. But we have to separate input output. So input will be today's sale and output will be sale after 1 month. Output will be sale after 1 month. For example, if you are having the sale, input data is sale of March 2015. Output will be sale of April 2015. Then if input is April 2015, then output will be May 2015. Means we have to separate that data. So in this case, RNN sequence is something different. Means we should have previous data as input and next data as the output. It's not like machine learning or basic neural network there. Previous data input and in sequence what comes after this input data is the output data there. Means in this data, whenever I build this model, what I have done, my previous data is given as input, like for example March 2015 input output data April 2015, which is already known to me. So I have used the input data itself to separate input and output like that. This is what model I have used, and accordingly the predictions are made here. Time series analysis. Time is not taken as input there actually. Output itself is separated in input output. Like, or sentiment analysis. Okay, when it rains it looks for a rainbow. When it's dark it looks for a star, something. It's positive sentiment. How do I know about it? I want to check sequence of the data basically. See, let's take an example. Have you solved sentiment analysis using machine learning? Machine learning algorithm. Like for example, in machine learning, we have to provide positive sentiment and negative sentiment, binary classification. And then you have to use the neural network to perform the classification of it. Anyone has tried it? So direct data as input is possible or not? Direct, if I want to use the string data as input to machine learning algorithm, is it possible? We have to, using which technique? Huh? No, sorry, it's not, wrong. No. Tokenization pre-process step, I want encoding, because algorithm numeric, na? So algorithm works on numbers. I want to represent this data into number, then only they can understand it. Which technique is used there? Vector embedding is fine, but vector embedding is used in deep learning, not in machine learning. Yeah? Target? No. There is nothing like that. Anyone other? Have you heard about TF-IDF vectorizer? Term frequency and inverse document frequency vectorizer. What it does, weightage of, means what they do, they tokenize the words. Means, for example, if I want to build a neural network, machine learning model for performing sentiment analysis, positive sentiment, negative sentiment, both are given. But they are string. I want to represent them in number, then only machine learning algorithm can understand. Not only machine learning, deep learning can also understand in numbers. See, whenever you type a question in ChatGPT, that model doesn't understand your string. They represent that data in a number, numerical form, and then they will perform the operation on it. Computer doesn't understand string ever, anywhere. They understand only numbers. Every algorithm of artificial intelligence can understand only numbers. So whatever data we are passing, that should be represented in number form, then only they can understand it. So TF-ID vectorizer process, which is in machine learning to represent this data in numbers. What happens in that case? For example, what it does, it separates the words and then assign the weightage to them. Correct. For example, in sentiment, positive sentiment, good word is there, and in negative sentiment, not good word is there. But make sure ki good is present in both the positions, and that's a separate word. So they will not use good word to classify the positive and negative sentiment, because both will be given same weightage, positive also, negative also, because we have separated the words there. That's why. The problem is they are not finding the word sequence. Ki not good is coming together, that's why it is negative, and only good is there. Is good is coming together, that's why it is positive there. It is not checked by the machine learning algorithm. It's not possible for them. In that particular vectorization process happens. That's the reason we have to find a sequence. Ki words are coming together, that's why it is negative. Words are not coming together, that's why it is positive. Something. There we are using recurrent neural network. Classification task. RNN is very effective for sentiment analysis in the large amount of data when they are present in this particular format. Great example of it. But today this task is done by transformer based methods. Language translation. Ki one sequence of words are translated in another sequence of words, like this. One sequence of word in another sequence of words. That is machine translation. Great application when started with neural network translation there. That time RNN was, but today, after my observation is, this task is done by transformer based methods, maximum number now, because transformer is giving good accuracy for machine translation based methods there. So what RNN basically, there are various models of RNN present, different types of RNNs. One to one, one to many, many to one, and many to many. What's the meaning of it? Before two, input and after two, output. Means one input, one output. It's possible to have. This is called as vanilla neural network. One input, one output. And under it we have recurrency. It's given back again. Okay, single input, single output. Second, one to many. One input and many outputs are there. This is image captioning. Like the example which I given. The dog is catching ball in the air. Image captioning. This is done by one input, multiple outputs. Okay, one to many. Third, many to one. Many inputs, many inputs, one output. Sentiment analysis, where a sequence of words are given as input and only one output, positive or negative, is taken there. This is called as many to one. And last, many to many. Language translation. Many words input, many words output. Okay, this is done by sequence to sequence model, encoder based models. This is the fourth architecture which is used. But current scenario, if you see current scenario, these models are not used much. As I mentioned, the transformers are having good accuracy over this. These kind of models are now converted into transformer based method like ChatGPT. ChatGPT's task can be done by this method also, many to many. But it takes too much time and accuracy is also not up to the mark. That's why transformers, whatever pre-trained transform we're using, they solve this problem currently. But RNN can also solve this problem, many to many. Okay. So basically, the problem is with recurrent neural networks are. First problem is vanishing gradient. See, what happens, why recurrence is created, they have to learn the sequence. But what the problem is, when sequence grows, 3 words are coming together, 4 words are coming together, 5 words are coming together, that time, the data will not be retained by RNN, because they are not having ability to store anything. And this problem is called as vanishing gradient problem. Technically, you can prove numerically, it's decreasing something. Vanishing gradient means, see, for example, whatever you have learned today, will remember almost 50% tomorrow, 25% day after tomorrow, 12% that after day. Like it's called a vanishing gradient problem. We also cannot remember many things for so long time if it is not important to us that time only. The things which are important, only that are retained, which are not important, that is discarded. Like summarization. If you watch a movie, you will not remember the whole movie. You will remember only which is very important part. Correct. And that you explain to your colleague, your friend, summary of a movie there. Correct. You cannot retain for max number of time because that is not important for you. This is called a vanishing gradient problem. The first. they struggle to maintain long-term dependencies due to the vanishing gradient problem in back propagation. Because they don't have memory and exploding gradient problem. Second, gradients can grow exponentially, leading to unstable training. That is also possible. They are learning too much things and they don't actually identify what to retain and what to forget, what to delete. That's a problem. It's called an exploding gradient problem. Okay, that's why RNN are not ideal for long sequences. Long sequences means sequence is very long. RNN cannot learn that much good from it, and that is the reason. See this one, for example, multiple stages are there, so loss of information through the time. When you copy the data from one hidden layer to second, second to third, third to fourth, it vanishes. Data will not be retained for so long amount of time, and that's why the RNN cannot retain the information. This is called as vanishing gradient problem. And second, exploding gradient problem. Exploding gradient, which I mentioned, if slope tends to grow exponentially instead of decaying, is called exponential means learnability is very high. It doesn't actually remember which information to retain and which information to delete. That time exploding gradient problem may occur. So it may lead to long training time, poor performance, and very bad accuracy. So see this one. For example, let's take an example. This example actually we use in neural network, but if I take the example, it takes too much time. Actually in practical, see this. For example, under what is the meaning of long-term dependencies? For example, a word is like this. The clouds are in the most obvious answer is sky. Okay, so we do not need further context to predict last word in the sentence. Simple, hai? Clouds are in the sky, because already they have learned sequence. These words are coming together, that's why after that sky will be there. Next sentence, hai? I have been staying in Spain for last 10 years, so I can speak fluent. What can be next word? Spanish. We can understand, we have learned it, we know that. We can connect the sequence words. But I want computer to learn this. If they don't retain the previous sentence, then how it is possible to identify the word after fluent will be Spanish? Not possible. This is called a long-term dependencies. They should know previous words also. Previous sentence also. They should retain that. This is called a vanishing gradient problem. So, see this one. So, next word is this. So, gap between the relevant information and the point where it's needed may have become very large. So, LSTM will help to solve this problem. What LSTM does? Wait a minute. What LSTM does? They are capable of learning long-term dependencies by remembering the information for long period to default behavior. And that is memory, long short-term memory. Short-term memory, short-term means it can retain information depending upon the amount that you have specified. It will retain the information for that amount of time. It's like a cache memory. Have you heard about cache memory? It's like a cache memory there. It will retain information inside the neural network itself. So, in standard RNN, repeating models are very simple in structure. They cannot retain this information. That's why LSTM is added. What is LSTM? Special kind of RNN designed to overcome limitation of vanishing gradient problem. It was designed in 1997, say, but it was not used. Idea was there, ki I want to retain information, so how to retain that? So create a memory. Simple. Okay, so they are capable of learning this. They use memory cells to store information over long sequences. Actually, RAM is used there. Whenever you build a neural network, they use RAMs, some part to store information present inside it. Okay. Controlled by 3 gates, input gate, forget gate, and output gate. Let us see this. See, this is the architecture of LSTM here. Means this cell, this is the LSTM cell. This is added inside the RNN. Means not RNN actually. Means this LSTM can be independently, separately also created, but the extension of RNN. They also contains output back to the input again. Okay. So it's containing 3 gates to control the flow of information and cell to hold the information there. Let us see this. You see this one, I just read out the name, I'll show the architecture of it, how exactly it flows the information there. This is your cell state here. Here the name of this gate is called as forget gate. This is called as the input gate. Okay. This is called as output gate. Okay. And there are 3 sigmoid functions are there. 1, 2, 3. And 2 tan H are there. This is the only location where tan H activation function is used. I hope you may be knowing what is tan H, what tan H does. Tan H output is in the range of -1 to +1, correct. -1 to +1, they are having 0 centric values. 0 is at the center, minimum value -1 hai, maximum value +1 hai. Okay, like this. Now let us see, I'll show you how exactly it does this work. Where is the LSTM? See this, just a minute. You see this one, same architecture I have shown. Whatever inputs which are passed, they will be passing from here, from the X. And they pass this information by calculating the gradients and store the information inside it. See, here one sigmoid function hai, here sigmoid, this is sigmoid function hai. 3 sigmoid functions are present over here. Here we have the previous state, this one. This state is passed as previous as input to it from here, and then it passes through all of them here. From the first phase, which is given over here, what was that? It is forget gate. Forget gate means there are 2 terms used, least recently used and least frequently used. I hope you may be knowing this one. Least recently used means the data which is not used for so long time. Least recently used. Definitely if it is least recently used, it is not important. We have to delete that. That is decided by this first sigmoid function. It generates the probability of retaining the information. If probability of retaining information is going below 0.5, it will be deleted. First. Second, okay, this one is done. Then second, input gate. So after forget gate decide, basically LRU concepts are used, least recently used. Concept is, if it is not used for so long time, because memory limited hai. If it is not used for so long time, it will be deleted. If it is used very recently, will be kept, and accordingly the neuron weights are decided over there. And they are generated as output. This one will be given as input to the next one. Again, this output will be passed as input to the next one here. And hidden state will be passed to the next hidden state of it. We'll go ahead. And to learn the weights. So the 3 activation functions are used. 3 sigmoid and 2 tanh are present over here. It's very detailed, but just in a summary, what I can say about this, in a summary, see, memory cell, they store the information over the time. We can define how many bytes you already defined. You have to store 16 byte, 20 byte, 30 byte, 100 byte, 500 byte, whatever. We can define. But remember, whatever memory size you are providing, accordingly it will take that much amount of time for training also, remember. Then forget gate, decide what information to discard. LRU concepts are basically used there. Means, as per data is coming, their weights will be changed. The information which contains very less amount of weight will be going out of the memory cell, because our capacity limited. That's why. Input gate determines which information to store in memory cell, and final output gate control what information from memory should be output, and that will be passed to the next memory cell in the sequence. That is output gate deciding. In short, what we can say, they decide the importance of the information provided as the input to it. That is what the LSTM does here. Okay, long-term memory. Long short-term memory. So it can capture long-term dependencies effectively. In short, they can prevent vanishing gradient problem, which I mentioned. They cannot retain information for so long time. That's why memory is added. Which memory is LSTM here? And where we use it? Yes, language modeling, speech recognition, machine translation. Means all the tasks which are performed by RNN, wherever you use RNN, their replacement is used. Currently, nowhere we also use simple RNN. We use either LSTM or GRU. Simple RNN is not used anyway. It was the main idea. But I'll show you. If your problem is very small, then simple RNN can be applicable. Fastest operation possible by simple RNN. In our example, I'll show you that one, where data set is not available. We have to create that. Then second is GRU. See, LSTM was taking too much time, and it was having complication in the architecture. Total 5 gates are used, 5 activation functions are used, 3 sigmoid and 2 tanh there. Remember, do you know which is the fastest activation function present? Means whenever I want to do the prediction, we consider speed. Correct. Which is the fastest activation function present? What do you think? Which is the fastest activation function? Yeah? Fastest activation function is? Fastest. Huh? ReLU. Why? Very good. Correct. That is correct answer. ReLU is fastest because No arithmetic numerical activity is there between them. Comparison है, greater than. But if you see the formula for sigmoid, 1 plus 1 divided by 1 plus e raised to minus z. E is there, raised to is there. Same case for sigmoid. Okay, e raised to z plus e raised to minus z divided by e raised to z minus e raised to minus z. That is soft math activation function. Too much complications are there to generate the result. Correct. Here 3 sigmoid A and 2 tan H A for only one cell there. So it will take too much time for calculations. Okay. So that's why they have reduced it. With the similar performance, GRU is created. GRU is gated recurrent unit. It doesn't contain the cell state. It contains hidden state to transport the information. Only 2 gates are there, reset gate and update gate. Faster, see this one. Here, you can see this one. Only 1 tan H and 2 sigmoids are used. Or later architecture modified. Means I want same output, better performance. Same output, better performance. So they have converted the 3 gates to 2 gates, reset gate and update gate. Reset gate is basically used to, it's like a forget gate, key which information to reset, delete, will be decided by the reset gate there. Update gate will update the weights of the data as is coming. Importance of sequence is updated by the update gates there. Okay, and accordingly will decide the outcome. That is what GRU does. So, what the difference that they carry is LSTM contains 3 gates, input, forget and output. GRU 2 gates are there. If you talk about performance, definitely GRU contains only 3 gates. So no complication arithmetic operations are there. They are typically faster to training. But LSTM is better for long sequences. Remember, it is slower. And memory, LSTM contains memory cell while GRU uses hidden state directly, where they do not have direct memory cells there. Which one to choose? See, GRU is chosen when small data sets are there or when computational power is limited that time. LSTM excels in complex tasks requiring long-term memory. When memory is very long, large amount of data, that time LSTM is used. Okay, that's what the difference between these two. One more thing, if I compare with RNN, see, LSTM is not the part of RNN. LSTM independent neural network. We can say that. Independent, it's extension of RNN there to retain the memory. In GRU also, GRU is extension of LSTM. They are in sequence. So RNN's problem was solved by LSTM, LSTM's problem solved by GRU there. But still they are having their own application areas where they are. But very rarely we use basic RNN. We call a simple RNN. Even bidirectional RNNs are also used where they are having direction from both the side, but they are very rarely applied and used over here. We'll see the application of it, where it is used basically. Where it is used. We have to use one program. Let's have that program also. There are NLP, natural language processing. Natural language processing is primary branch of AI there. Under AI, computer vision and NLP, these are the 2 top branches are there. Where in NLP, we try to understand the human spoken language, NLP. And computer vision, we try to understand videos, images, what we see. We analyze by the help of computer vision there, where CNN is used. But in NLP, we are using RNN, recurrent neural network, where data is basically containing a sequence. Okay. Speech recognition is also part of NLP. Time series forecasting, weather prediction, financial forecasting, animal detection. I have designed one application also where on Kaggle we are having one data set. How sea levels are changing. Sea level is changing. That data set is available on Kaggle. Using that I can predict in next how many years which cities will go underwater. Possible hai. Already data set available hai. Into 1901, what was the sea level present? 1950, what was the sea level? And in 2001, what was the sea level? Accordingly, if same trend continues, what will happen in future, I can predict. That is coming at time series forecasting. Possible. Autonomous systems, robotic, self-driving car, action prediction, there also it is used. There is a term called as reinforcement learning, maybe if you heard about this. Reinforcement learning and RNN are combined together in self-driving cars to perform the prediction, driving predictions basically. These are the application where we use it. But let us see our practical application where we can apply and use it over there. Now, my focus is to learn the sequential modeling here. I have taken very basic example of RNN. We'll try to understand how sequence learning means. What's the meaning of sequence learning? So whenever we have to learn the sequence, and how do I decide our data set and how to perform the operation ahead of it, that we will see here. Any question if you're having here, because we don't have much time. Practically will take some time. So if you have any questions, You can ask. In practical also we'll see the similar things, how to build it. We just have to log in to Jupyter Notebook or Google Colab. There also you can do this practical without any data set. I'll show you what is sequence learning and how to learn the sequences. Is any question till this point? Any question before working practically here? Yeah. Any question commonly? Actually, terms are very big here, but my primary focus will be on this practical part. We'll try to understand the meaning of it. Yes. Huh. Correct. Exploiting, correct. Yeah. Okay. Huh. Okay. Correct. Good question. See, there is a, do you know which is very frequently occurred word in the sentences? Very frequently occurred word. Huh? The. Now see, actually the is not important in artificial intelligence. When you have to do some prediction, the is not important because the stop word hai, which is not that much important. Ki I want to do the classification sentiment analysis. So the is important, not important. The will come in positive also, negative also. Correct. What will happen whenever you train the algorithm? The is coming very frequently. So recurrent neural network will identify that the is very important. Correct, because it's coming very frequently, and the word which is coming very frequently is very important there, and it will give higher importance to the is there. But actually, for classification, the is not important. This is called an exploding gradient. This is rare, special situation. This is what the situation. The is giving a higher importance because it's coming very frequently there, and it's from classification point of view, we cannot use it for classifying it there. Means you are getting more information to that particular word, more weightage to the word over there. It's called as exploding gradient. And vanishing gradient we know. Okay, exploding gradient is not very commonly occurred, but in these are the situation where exploding gradient is possible. Okay. Any others? Yeah, anyone else? Okay, fine. Okay, let's take an example, very basic example. Do you have Google Colab, correct? So open the Google Colab. We'll see a very basic example of it. Try to understand what's the meaning of sequential learning and how RNN is basically used for this work. Just create a new file. So I built the code already to save the time. So let us see one by one. Let's elaborate the problem first. See, have you heard about predictive typing? Predictive typing means whenever you start typing in Google Mail draft, words are automatically coming. Okay, for example, if you are given the mail ID, you type the mail ID and you type dear. So whose mail ID is that? Whose name will automatically come after dear? Correct. It's called as predictive modeling, predictive typing. Or if you type please find, it will show attachment automatically. You just have to put a tab to auto-complete it. Correct? How they know about it? Because already the Google Mail has learned over the time that these words are coming together. That's why they are always in sequence. They are always in sequence. And that's the reason they are predicting. If this word is there, definitely another word connection to that will be like this. Or if you write thanks, will show regards automatically. How it is possible? Actually, we require huge amount of data for that. Like the ChatGPT has learned on the whole data set, data available in the world there. So that data is tremendous that we cannot use there. But definitely data was used over there. Here also you have to use some data by which they will learn the sequence. So let's elaborate. We'll learn the alphabet sequences. I'll give alphabets as input A to Z, and we'll learn it We'll train the algorithm for A to Z. And next time, once they have learned, we'll pass one character as input, algorithm will predict the next character as output. Fine? Very simple. I don't have data set, I don't require data set for this. We have to build by our own. But what steps are required, that we have to remember. Getting, for example, when the model is trained, I'm giving cube, will generate R afterwards. If I'm giving C, it should generate D afterwards. Means they will learn the sequence of alphabets, and once they have learned, I can use it for prediction. So definitely, usage of every machine learning, deep learning model is prediction. Okay, they are learn and they will do the prediction ahead. So how this sequence modeling is done, that we will see. So first of all, I think all of you having Google Colab, we know how to handle it, use it. By default, all the deep learning, machine learning libraries are there inside Colab, they are available there. Okay, so let's go. So for example, alphabets. Okay, just create an alphabet sequence here. I want computer to learn this sequence here. Okay, so create the alphabets. Same case, whenever RNN require the data input, you should have a data which is containing a sequence present there. That is mandatory. It can be any type of sequence, like example which are shown there. Okay, two things that you have to remember. Every ML algorithm require data to be in number form. This data should also be in number form. Wait a minute. Is it visible here? Okay. This data should also be in the number form, alphabets. And for RNN, I have to decide what is my input, what is my output. What do you think? What can be input, what can be output here? Yes? Yeah? Correct, very good. That's what I told already in time series also. Input data sequence, but I have to decide input and output. So if A is input, B is output. If B is input, C is output. If C is input, D is output. I have to decide it. These two requirements, number form and second sequence form, input and output. Correct? Okay, so I have to represent this data in number. Do you know any function which does this work? Key, I want 0 means A, B means 1. Is there any Python function does this? No. The direct function which I can use to find the index values of these particular characters. No. Default enumerate function. See that. Enumerate the alphabets. Sorry, list. Find a list of it. See. So basically, I require two lists, two dictionaries rather. First will represent character to number for encoding, and one algorithm has generated result, we have to decode again. But they will generate numbers. I want to generate characters there. So decoding list, one more list we require there. Enumerate. Using that, I will create two different dictionaries. One dictionary will be character to integer, and second will be integer to characters. Because whenever I am passing the data, I am passing string, but algorithm takes number, so I have to encode it to number, and algorithm will generate numbers, but I want in character format. So again, I have to decode it. Remember, and this is the case for all algorithms. Not talking about RNN. In machine learning, deep learning, everywhere same concept is applicable there. Okay, so you have to create two different dictionaries here. Using list comprehension, we can do it. Just a minute. See this. See, first one, we are creating a dictionary of it. I am converting to dictionary format. If you see int to char, we'll have something like this. Key integer and value character. Okay, I have to represent in character form. What's the meaning of numbers? That will do. Enumerate it. And this is applicable for every kind of data. Actually, RNN building is very big. Means I'll show few examples also here. Just a review at the end of this session. Okay, how big algorithms are basically being used. This is very basic example. Okay, first one. Enumerate. Int to char, it is used for decoding, and one I'll use for encoding, character to integer there. So whenever algorithms are trained, we have to represent in numerical form, and for that purpose, char to int is also required. See the char to int. So this is integer to character, and char to int we are going to do using dictionary comprehension. I hope you may be knowing one concept called as dictionary comprehension. Have you learned about list comprehension? Do you know list comprehension in Python? List comprehension. Don't know. Means creating a list from another list. Dictionary comprehension means creating a dictionary from another dictionary or another set of key value pairs there. So what I've done here, okay, see this one. For I comma v in enumerate alphabets, so it enumerate it, first index is taken, second value is taken, but when I'm storing it, I'm storing value first and then index. So this is created. Char to int. See this. Means key character hai and value 0 hai, that is number hai. This is used for encoding, and int to char will be used for decoding. Yes. Just do this. So our input data will be ready, and whenever actual data is there, like I mentioned about Google Mail predictive typing, then also same concept is used. But there, these numbers are going above 40,000, 50,000 because data is that much big. And their tokenizer and very advanced concepts are used. Word embedding is used, vector embedding is used, where by default, same concept hai, but they are using with the help of libraries because that amount of data is available. Here it is very small, that's why directly using this internal method. Is it done? So two things I have created. One I am representing character to number, second number to characters. Okay, encoding and decoding we can, because neural network cannot learn directly from character. They will learn from numbers, not from characters. Okay, getting? Okay, fine. So now see, we can identify, I hope you're knowing dictionary concept. From int to char, if I write int to char, for example, which character is present here, you can find, okay, and which number is present here, that we can find. Fine, it's a dictionary. Now I want to represent my input data, basically input data and output data. So for that purpose, see this, I have created x and y here. So I'm creating x and y. X empty list, y is empty list. Now we can see, I want, let's say input data hai 0, 1, 2, 3, 4, 5, 6 till 24, and output data hai 1, 2, 3, 4, 5 till 26. Correct? 0 means A and 1 means B, like that. So for that purpose, I'm using X as empty list, Y as empty list, and I'm iterating through this. For I in range, total number of alphabet minus sequence length means one character input, that is what the sequence length is given. We can later modify that. If your sequence is larger, my sequence length 1 means A is input, B is output, B is input, C is, that is sequence length 1A, 1. That's why I've taken 1 there. Okay. So sequence input is alphabet of I, and sequence output alphabet of I plus 1 means next character in the sequence, I plus 1, correct? That is taken here. And which letter is, which number is present that I have taken here in X, and same is in Y also. Means sequence ins number is in X and sequence outs number in Y, because I want this data to be in numerical form, not in character format. That's why I've taken there. You can see this one. See, A is input, so B is the output. What I've done, I plus 1, next one. And their numerical representation means sequence ins numerical representation is in X and sequence output numerical representation in Y. That is taken. One special idea I've used here. Here I have added as a list format because this is a requirement for neural network. When you build it, your input data should be in multi-dimensional and output data in single dimensional. That's why I've taken this one. Double L, list is taken, here is not list. Direct data hai, and here it is list hai. Check this. Using what my final aim is to assign the numbers to them. A, B, B, C, C, D, that is okay, I want to learn. But I want numerical representation of it. Like 0, 1, then 1, 2, then 2, 3, 3, 4, something like, I'll show that. When you print X and Y, you will get this. X contains 0 to 24, and Y will contain 1 to 25. That's it. And I just printed this A and B here, sequence in and sequence out. This is what shown over here. Sequence in A, sequence out will be, so B is input, C is output, C is input, D is output, something like this. And whenever you build any other RNN, everywhere you have to do in the same method. Not in this method, your data should be in sequence, input, output, and numerical form. That's a requirement. And for that purpose, you can use any method to do this. There are various methods present to do it. Check. Here I am using one hot encoding method. I hope you are knowing one hot encoding. Sorry, label encoding method, not one hot encoding. Label encoding. Label encoding means in character sequence, they are assigning the sequence of numbers. That is called a label encoding, which is given over here. Try that, you will get this output because I am printing it here. Sequence in and sequence out. Check it. In large corpus of data, we are having a technique called as continuous bag of words. CBOW, that technique is used. But similar method hai. Here I am doing from scratch. There directly libraries are there to perform the continuous bag of words. Which words are coming together. So they are assigning numbers to them. So depending upon the corpus of data, 1 lakh, 2 lakh numbers will be possible there. But this is common technique used here. You have to represent in numerical form something like this. Okay. Done? See, sequence length I have specially created data. Specially created, why? Because I can change sequence length in future. Like if 3 are given, A, B, C, then what can be next word? D, it should be predicted. So sequence length will be 3 in that particular case. Currently I am focusing only 1:1. We can later modify it to 3, 4, 5 also. That's also possible. So my input data is A, output data is B. Input data is B, output data is C. This is there in, sequence out. But X and Y contain numbers. Label encoded numbers. Is it done? Can we move? Can we move to the next? Getting? Yeah. Let us see. So the sequence data is, you can check X and Y. Print X and Y. Check X. X is your input data, like this. Numerical representation of that characters. Okay. 0 to 24. And what Y contains? See Y. What Y contains? Yeah. 1 to 25. 1 to 25. Like this. Fine. X and Y. Our represented data here. Okay. This one will be the output, something like this. We'll have X and Y will be present. Now, one more thing. We have to prepare our input data. See, the requirement of algorithm is always like this. Ki our input data should be in a specific dimensions there. Specific dimensions. Means how many characters are there? Total input 25, total output 25. See this one. If you see the X is two-dimensional data. Two-dimensional data. Here you can check it. 0 to 24, 2 dimension. But it's in list format. List cannot be taken. We have to convert it into array format there. So for array, we have to use NumPy array. I hope you might be knowing NumPy. Knowing NumPy? Numerical Python. Array. Arrays can be created using this particular method. Import it and reshape it. See, if you check the shape of it, reshape, why reshape it? Total number of rows, total number of input data, how many number of characters are there in single entry, and what is the length of sequence? That is the third parameter present over here. Maximum length of a sequence. See, How many letters are there? Maximum length of the sequence, that is given over here. That is also 1. And how many entries are there? That is also 1. When data is large corpus, that time you have to use some different methods to work on it. Different method means what is the maximum sentence there that is required. But currently I don't have that. Just reshape it. Reshape. Total 25 rows. Sequence length is 1. And total characters present in single, maximum total character is also 1. That's why 1 is given. That's the requirement of algorithm actually. Requirement of your library actually. Library which is used. Keras library which we will be using. That's why we have to do reshaping of this data by using this method. Okay? Reshape it. This reshape is possible only on the arrays, not on the list. That's why I am using reshape function from NumPy. I hope you may be knowing NumPy is specially used for array operations only. Okay, done? Getting? Input data should be represented like this. Total number of entries, sequence length, and maximum values present in single character. That is also 1. Same. These numbers can be different if your sequence length is different over there. Fine. If you see this array, it is something like this. Okay. Like a concept similar array. Fine. Now next, we have to scale the data. I think you may have heard about scaling, feature scaling. You know the scaling concept? Scaling. What's the meaning of scaling? Feature scaling. In machine learning, it is available there. Means, for example, if multiple features are there, all these features we have to weigh equally. In order to weigh all the feature equally, we have to use min-max scaling. There's a formula for that. X minus x mean minus divided by x max minus x mean. It's used there. But when your minimum number already 0, you have to divide by maximum number. So data will be scaled in the same range. That's called as scaling. And to do this one, we are going to use this formula. Simple. Divide with the maximum number. Maximum number 25. And you can see the result. Data will be scaled in a range of 0 to 1. Something like this. See this. Divided by 25. Okay, divided by 25. So data will be scaled in the range of 0 to 1. You can say this one. It's scaled in the range of 0 to 1. Minimum value will be 0, maximum value will be 1 always. That's the use of scalar. Just execute it only one time, remember. If you execute multiple number of time, previous value of x will be used. Fine. So we have scaled this data. Scaling is the one of the primary requirement of the algorithm there. This is what we have scaled here. And then output data we have to prepare. For output data, we require data to be in the one hot encoded format. See this? We'll go with the output data. If you have done the multi-class classification, so this problem, whatever I'm showing here, this problem is multi-class classification problem. Correct na? How many classes are there as the output? How many classes are there? 20? 25. 25. B to Z. A is not the output. 25 classes are there. Multi-class. That's why in multi-class classification we have seen we have to perform one hot encoding. So using two categorical function we can do this one. See, for example, y new is equal to 2 categorical y. And if you see this y new, I hope you may be knowing what's the meaning of one hot encoding there. See this? One hot encoding. Total 25 letters are there for 25 classes. And wherever that class is present, there 1 is present. For example, the first line here 1, means this is 1. This is 2. Means column number 2, column number 3, column number 4, column number 5, column number 6, column number 7, something like this. At which column number the value is present, there 1 is noted. That's called as one hot encoding. I hope you may have seen that in deep neural network. For every multi-class classification, one hot encoding required. Because this problem is this problem multi-class classification, because we are predicting 25 classes from this. That's why it is required. Just do it. Okay, done. Same function which is used for one hot encoding in all neural networks. Now, our data is ready. Data is ready for performing the classification. Let's build the neural network model. Let's build the model here. Okay, in order to build the model, we have to import our classes. Which one? Our sequential class. Sequential class from the keras.models. Dense class for densely created simple RNN. Simple RNN for RNN building, and input for input data. Input layer basically required that one. And then we'll build the model. Check this one. Simple model I am creating here. Neural network model. Where input one by one, 25 total letters are there. Input is one by one. And then densely created network, neurons are created, 25 total neurons with activation function ReLU. After input layer, okay, inputs dimension one by one, total 25 rows are there, and one by one is the size of individual entry present in 25 total letters present there. And then I'm getting simple RNN with 32 units, okay, 32 units are there for simple RNN, and at the end, total 26 classes I'm predicting here, where activation function is softmax. Why? Because multi-class classification problem, that's why. 26 classes are there. Remember, why 26 are given, specially. What may be the reason? 25 classes prediction, na? 26 is given. What do you think? I hope you are knowing the meaning of last layer. Whatever number of classes predicted, that number of neurons you are passing. Here total classes are 25, but I am given 26. What may be the reason? Actually, if you see one hot encoding, see, in one hot encoding, you can see total classes 26 hai. Correct na? Total 26 classes hai here. Why? Because 0 is also considered. 0, where 0 is not output, but it is considered while one hot encoding. One hot encoding always considers from 0 onwards. It is not there in the output, but still 0 is there. For 0, probability for all 0 is 0, means it's there in the first column, but nowhere 1 is written. Okay, that's why 26 are given. Total number of columns in Y are 26. That's why 26 classes are given there. Softmax, because multi-class classification problem, that's why given softmax activation function. What to do after this? Yes, what's the next step after building a neural network? Simple neural network. Input one by one at 25. Simple RNN we have to use. How many units you want to pass? That is 32. Any number you can pass there, but this number is also very large. 16 will also work for this because data is not that much big. And activation function is softmax. Multi-class classification problem, that's why. Only one dense layer. Number of layers we can increase, but for this problem it's not required because it's very simple. That's why. Okay, after building the model, what's the next step in neural network? Yeah? Yeah? Fit? No. One step is remained. One step is remained already. What is remained? Alright? You don't know. Basic neural network, if you have worked on it, you might be knowing one step has remained here. Which step has remained? Compiling is remained. Compile. You have to compile the neural network. Correct? So compile it. So let us see. Let's compile that. Plotting is also not required. Let's compile and then train it. Let's compile the model using same functions which were used. Our categorical cross entropy. Why? Because multi-class classification problem, that's why. Then optimizer, Adam, standard optimizer which is used for multi-class classification, matrix accuracy, and then train. So for training, I'm using 500 epochs. Data is very small. It will take very small amount of time to train. X input, Y new output. Epoch say 500. Batch size is 1. Batch size also not required. By default 32 hai. So data is very small. That's why it's not required to have that. Go ahead. train the model and check the accuracy. 500 epochs are given. So we'll run with 500 epochs. Compile is same function which I use for multi-class classification. Categorical cross-section. Here sparse can also be applied, but categorical is okay. Optimizer is Adam to learn the ideal efficient weights. Matrix accuracy, on that we are going to train it. Is it done? Yes, anyone has finished? Or any error is there? Do you have any error? It's running. It's taking too much, it's a very small amount of time, let's say 7 milliseconds to 5 milliseconds around for one step. Is it done? Yes, anyone has finished? Not yet. Huh? What's the final accuracy? 97. Okay, good. 97% accuracy final. चालू आहे. अच्छा चालू आहे ना, ठीक आहे. जस्ट अ मिनिट. इथे ॲक्च्युली क्लोज झालं माझ्याकडून. हां, जस्ट अ मिनिट. Yes, how many have finished? Around 96-97% accuracy will be present. If you go to 1000, maybe possible to have 100% accuracy also. That number of epochs. हां, बंद झालं ते ॲक्च्युली, म्हणजे हां करतो करतो. हां, ॲक्च्युली ते मला वाटते लोड जास्त झाला त्याच्यावरती. हां, करेक्ट करेक्ट. नाही असं काही नाही स्पेशल. नाही नाही, लॉसचं काहीच नाही. लॉस म्हणजे 100% ॲक्युरेट असेल तर 0 लॉस होईल तुमचा डायरेक्टली. हां, जस्ट अ मिनिट. शेअर इट. आले ना? ओके. Yeah, I'll run it again. See, so it trained it. It was disconnected. Huh. Yes, yes, yes. Okay. So it's running. You can see the accuracies. One more thing. See, you check it out. Here, one small modification I made here. You can check this one. Ki, for example, when I'm giving a previous letter. नहीं सर इथे Google Meet ला आहे. Okay, see this one. What I've done, I want to do the predictions now at the end. Okay, when new letter is present, then if new M is given, what can be the next letter present in it? So M is new letter. I want to do the prediction, so I have to perform all the pre-processing again to perform the prediction. What I have done? So first of all, from M, what's the number that M contains that I have retrieved? Then I have reshaped it to 1 by 1 by 1. Okay, one row, one width, and one sequence length there. Then I have divided by 25, that scaled the data. Then I have done the prediction. I hope you might be knowing, predict function generate the probability. How many probability? 26 probability will be identified. Correct? Because sort math activation function is, that's why. Correct? So prediction will be there. Where highest probability is present, that is your answer. So I got this prediction probabilities, and using argmax, I'm getting where the highest probability is present. Here it is. And whose probability is that? That I want to decode again. So the prediction number which I'm getting, which character is present there that I'm predicting. So when I pass M, I'm getting next letter as N. See this. Prediction on new data. So you can change your letter. You can pass Q, you can pass S, you can pass D, you can pass F. And do all the processing. Integer conversion, then reshape it, then scale it, then predict it, and then find where highest probability is present, where it's present, at which index position, and which letter is that. That is identified. So when my new letter is M, it can do the prediction N because it has learned the sequence. My new data is fast. It can learn what can be next letter present in the sequence, that is N. It's taken out from there. Check it, try this one. If it is coming, you change your data and see the result. Wait a minute, is it still running? Check it. Only this part. Try this and see the result. All in machine learning also, deep learning also, whenever you are doing prediction, whatever data you are passing as input should be pre-processed in the same way that you are used for actual model building. So for pre-processing actual model building, we have converted character to number, then we have reshaped it, then we have scaled it, and now after that we are passing in data as input for prediction. Prediction will generate a probability, sort math probability here. So which probability is highest, that I want to find using argmax function. So, and which number is present, which letter is present over that position, that I want to find. That is predicted here, that character is N. When M is given as input, next letter a N as the output from there, which is your final answer. So you change your letter and do the prediction. Again, all pre-processing, prediction, and then decode it. Decoding is required for every recurrent or any neural network, not RNN only, everywhere. The decoding is required. Whatever encoding you have done, similar decoding we also required over here. Try that. Check the answer. Anyone's got the answer? You change the character, you will get a next letter there because they have learned the sequence. The data that you have passed, using that they have learned the sequence. Here, see, instead of simple RNN, if you use LSTM, GRU will also work. Actually, for this problem, even LSTM is also not required. Don't waste the memory because only one letter and one letter output. So they don't require to store for long-term dependencies. This is a problem which can be solved by using simple RNN also. But instead of that, you can write LSTM. LSTM capital letter, it's a layer that we can import from the layers and we can use it directly. That is also possible. Yes, how many of you got the output? You change the letter and see the result. Working. For every letter, it will work. Now onwards, I can use this model to perform prediction for any letter. If this letter is previous, what can be next letter there? Because they are learning using the data. Yes, ma'am? Last is not possible. So we have to modify. After Z, you try that, it will generate some random result. Random means where probabilities are, because it always generates probabilities. Whichever contains highest probability is not there. So if you want to do that, again connect Z with A, or after Z you can type small a, B, C, D, like that. That's possible. After last is not possible to do the predictions. This is a simple example. I just want to know what is sequential modeling using RNN. So data can be of any type. It can be any type which contains a sequence present inside it. And you can do the data in this particular method. Fine. Is it okay? Even below to this code I have given the sequence length change also, but we do not have time right now. You can try later. You can have 3 characters and 1 character output. That is also possible. Okay. The minimum that number of characters are there, then only output can be possible. Currently we are given minimum 1 character input, 1 character output. So 3 characters input, 1 character output, that is also possible, which I have given. I'll share that code also. So you can try. We have uploaded that on GitHub, on Mithus Kilology's GitHub account. There also this code is available. You can download. Not only this one, many different codes where predictive typing is used, our time series analysis is there, language translation is there, sequence to sequence modeling is there. They all can be done with the help of RNN. You can try these codes also. Fine. Yeah, anyone is having any error, any problem, any queries, questions, doubts? This side. Is it working? Actually, in a very short time you have taken this. You may revise this concept again and try to understand. And if you have any questions, so you can put me a mail also. I have given my mail ID there. Yes, here, is it working for all? Everyone. Sequence modeling, that is primary aim of recurrent neural network. You change simple RNN with LSTM. See, for example, here, both are there. LSTM also present and GRU is also there. And you try with only LSTM, right? LSTM and run it. Will not get difference in the result actually, because the requirement are satisfied by simple RNN also. That's why LSTM will not have any impact in the result, even GRU also. But when it is impacted, when you have large amount of data and long dependencies are there, that time simple RNN performance drastically decreases. Then LSTM you have to use over there, or GRU you have to use. So LSTM GRU can be considered a separate neural network as an extension of recurrent neural network over there. Fine? Yeah, if any questions or any kind of doubts if you are having about this, you can ask. Yeah. Bidirectional. Actually, this simple RNN can also be actually, in simple RNN only single is given. Bidirectional means input to output, output to input both are present there. There is only special area where bidirectional LSTM can be used. Bidirectional RNN also available. Bidirectional LSTM is also there where we can use it. But when, which situation we can use? Wait a minute. See, some kind of languages are there. For example, your input data is in Devanagari script and output data in Arabic script. Devanagari script is written from left to right and Arabic script is written from right to left. So in this kind of translation, if you want to perform, that time bidirectional LSTM perform perfectly because it can read data from both the sides. Can perform from both the sides. There effective situation where bidirectional LSTM can be used. Bidirectional RNN is also available, that can also be used over there. When I want to learn the sequence from both the sides, from forward also and backward also, that time only we have to apply and use. Yeah. Anything else? Okay, so I have given my mail ID here. You can, if you have any questions, so you can send on my mail ID also. This one. Fine. Okay. Ma'am, we'll stop here then. Okay. Thank you.
As we come to the end of this insightful session, I would like to extend my heartfelt gratitude to our esteemed speaker, Mr. Tushar Kute sir, for sharing his invaluable knowledge and expertise on recurrent neural networks and long short-term memory models. His deep insights and real-world experience have undoubtedly enriched our understanding of advanced deep learning concepts. A special thank you to our faculty members, organizers, and participants for their enthusiastic involvement, making this session truly engaging and productive. We hope this session, along with our previous session, has provided you with a solid foundation to explore deep learning further and apply these concepts in your future endeavors. Let's continue this journey of learning and innovation together next week. I request everyone to fill the feedback forms that, like, I'll share the link and the QR code, so please fill up the form as well. Thank you so much.
हा फॉर्म भरायचा आहे का?